All right. So if we think about maybe G being sort of like fluid intelligence combined with some invoking of crystallized, what about other kinds of intelligence? There is practical intelligence. I mentioned this already, that this is part of Sternberg's model. This idea that you might have street smarts, that your day-to-day functioning is supported by your practical intelligence. There are some examples, right, of practical intelligence. A person who knows how to, let's say you need to go do some errands and you want to do it as efficiently as you possibly can. A person with practical intelligence would be able to sort of map out the errands, knowing that maybe one of them you have to do it by 10 a.m. The other one needs to be done, after 11. And, you've got all these constraints that you have to juggle and figure out. It would take practical intelligence to be able to figure out the problem and, end up with a good, efficient approach to your daily errands, right? So practical intelligence is the kind of thing that, sort of enhances your ability to function in life. Rationality is, the capacity for critically assessing information as it's gathered in the natural environment. So rationality refers to your ability to sort out fact from fiction, to be skeptical when necessary. Those kinds of things are all part of rationality. And some of us, we naturally kind of are more rational, and some of us are more whimsical, I guess, might be a good way to say it, are more ready to believe things that aren't necessarily rooted in logic. And I like this example of intelligence beyond the IQ test, because this isn't something that we measure, but probably people differ on this category, and probably have some strong feelings about which side of it is actually the more intelligent side. Is it more intelligent to be rational, or is it more intelligent to be more open to alternative explanations, right? So it's not just the G factor or fluid versus crystallized intelligence or something that people argue about. There are, the practical street smarts people argue about, like what would good practical intelligence look like? What would good rationality look like? How about emotional intelligence? This is a really hot topic that people argue about. The definition of emotional intelligence is our ability to understand our own and others' emotions, and then also to control our own emotions appropriately. And I happen to teach a class called Emotions and Emotional Intelligence. And in that class, we talk about emotional intelligence, and a lot of students really want to hear all the great things about emotional intelligence, but then are very disappointed when they find out that there's not a lot of like empirical support for even the existence of emotional intelligence, let alone quantifying it and things like that. People are still debating whether this is a special kind of intelligence or not. Is it just a manifestation of G? Actually, all three of these people have said, oh, that's just a manifestation of G. So all of these are just subparts of general intelligence. So there's not an agreement on even these, and these aren't things that are normally tested as part of IQ. So the whole thing's controversial. But this brings me to a model that you may have heard about growing up, because it's gotten really popular in like the K through 12 education system, to assume that people have multiple intelligences, that there's lots of different ways to be intelligent. And so this comes from Gardner, and I thought I'd point out a couple of interesting things about this. First off, let's just go around the circle. And so at the top right there, we see musical intelligence. Below that, you see kinesthetic. This is obviously somebody from the UK made this because they spelled kinesthetic in the UK way. Interpersonal refers to your ability to get along with others and recognize their emotions and their motivations. Linguistic is your verbal intelligence, which should look familiar because it's been on all the other intelligence tests so far. Logical, same thing. It's on the other tests. Naturalistic, this is your awareness of your role within the environment. Visual spatial is sort of artistic, as well as like three-dimensional kinds of moving around in space and things like that. Intrapersonal is your ability to recognize your own emotions and your own motivations, soothe yourself when you're upset, those kinds of things. And then existential is, recognizing the purpose in life and why you're here and things like that. Maybe interpersonal and intrapersonal comprise emotional intelligence, right? Sounds a lot like the definition of emotional intelligence, right? That you can regulate your own emotions, you can recognize your own, you can recognize others. That sure sounds like the definition of emotional intelligence. So maybe Gardner's model addresses that. And then general intelligence really would be measured just in Gardner's linguistic and logical intelligence. That those two parts would be all that's normally measured in a regular IQ test. Some people have criticized this model and said, kinesthetic, musical, visual, spatial, those are just, those are talents. And existential and naturalistic, that's moving even beyond talent and looking more at like ways of being rather than intelligence. So people have attacked this model and said it doesn't make sense or that it's not helpful, things like that. But we do know that there are some interesting things regarding it. One is that on average, males do tend to score higher on spatial tasks like mental rotation, and that females tend to score better on linguistic tests, whether it's reading or generating a list of words that rhyme or any measure. Females tend to do better on those kinds of linguistic things. So we know that there are some sex differences between males and females on those two things. So that starts to open the door to, like, what is this? What are we tapping into? Why would there be sex differences and stuff? So, and then the other part is it really seems to explain savant syndrome, right? You have a person who has lower scores on a traditional IQ test. So their linguistic and logical scores are lower, but then they're really good at art, or they're amazing at music, or they may have like counting abilities, or these things that are well beyond what you would expect. And so savant syndrome may be illustrating that these different kinds of intelligences might be housed in different parts of our brains. And that even if you get damage to the part of the brain that's traditionally associated with intelligence, the other areas may be fine, or maybe even get the opportunity to grow and develop beyond what they would have otherwise if they'd had the constraining components of the traditional intelligence. And the fact that we can induce savant syndrome temporarily in a person by sort of shutting down their linguistic logical areas kind of supports that idea that maybe different regions of the brain handle different parts of our intelligence, at least as defined by Gardner's model. So kind of interesting stuff. I thought you might enjoy this. I'm going to put this in the viewing list. Here's an example of a person with savant syndrome. In case you're wondering at all, like, what do you mean? How can this be? Here's a person with savant syndrome who can draw just from memory after viewing a cityscape in like a helicopter tour. He can draw it just from memory. So that's what we're talking about with that kind of savant syndrome. All right. So where does intelligence come from? We have to acknowledge both the role of genes and the role of environment. They both play a role. Do they play an equal role? Probably not. The research is sort of settling on the idea that intelligence is probably about 60 to 75% due to genes, and the rest is shapeable by the environment. Where do we get those kinds of ideas? Well, one way that we get those ideas is from studying twins. So monozygotic twins are twins that start out as one zygote, one fertilized egg. So they're called monozygotic. So there's one fertilized egg that splits into two individuals that implant and successfully make it to birth, right? So monozygotic twins share 100% of their genes in common. They always share the same womb at the same time because they're twins. They might have the same placenta, which is the part of this giant organ that implants in mom's uterus and collects nutrition and oxygen and gets rid of waste products. They might have the same placenta. They don't always, but they more often than not have the same placenta. They might be in the same amniotic sac, which is the thing that contains the baby within the womb, and it's got, the water and all the things that the baby's floating in. monozygotic twins might actually be in the same sac. And so they actually are floating in the same water with each other. They might be in separate amniotic sacs, however, so it's not a guarantee that they'll be in the same one. But so from the very beginning, they have a very shared environment compared to other, even compared to a dizygotic twin, which is the green bar. Dizygotic twins are when you have two eggs that are fertilized by two sperm in the same menstrual cycle. So you end up with twins. They're basically regular siblings, but they're in the womb at the same time. They always have their own placenta. They always have their own amniotic sac. So their environment in the womb is a little less similar than it might be for a monozygotic twin. Dizygotic twins and regular siblings share about 50% of their genes. Dizygotic twins differ from siblings in that siblings are not in the womb at the same time. So they differ by at least 9 months of age, right? Dizygotic twins are the same age. And then we have unrelated individuals who are in different households. So these are just like strangers on the street. So what we're seeing on the y-axis is how much similarity the two people being observed have. And so this is going to be represented in correlation coefficients. So we have monozygotic twins, we administer intelligence test, and then we correlate their scores together. If they were reared together, that is, they lived in the same household while they were growing up, the score of one twin will correlate with the other twin at about 84%. So 0.84. So that means that that monozygotic, if I knew the score of one monozygotic twin, I would be right about 90% of the time. I would be right just by guessing that the other twin has the same score. If they were reared apart, my ability to predict would go down a little bit. So they're more at like 0.7 correlation. So now I'm looking at maybe 50% of the time I'm going to be accurate if I just guess that they have the same score. Dizygotic twins go down even further. So now dizygotic twins only sharing 50% of their genes, but they were in the womb at the same time. They have about a 0.6 correlation between their two scores. So if I just guess that one's going to have the same score as the other, I'd be right about 36% of the time. And then siblings who are reared in the same household. So these are same amount of genes as a dizygotic twin, 50% of genes in common, but they're siblings, not twins. And so they weren't in the womb at the same time. So we lose that predictive capability that, the dizygotic twins have. So it's down to about 50%-ish. And so about 25% of the time I would be correct if I just guessed that they have the same score. And then strangers in different households, their scores correlate at, less than 5%. So the more closely related you are to a person, the more similar your IQ score will be to theirs. But you see the stair step effect as you go down. So you've got monozygotic twins, so they got 100% of their genes in common, and they were reared in the same household. So overlap of genes and environment. That's our best predictor. But if you take away the shared environment, go to the orange bar, you find that you drop off, right? And you drop off almost the same amount as you do if you go to dizygotic twins. So now we don't have as much genes in common, but we share the same environment. So if you change the environment, you lose predictability at the same rate as if you changed genes, right? As you become less related, you step down. As you become reared more differently, you take that step down. So we see from this chart a lot of evidence that both genes and environment play a really big role in determining a person's intelligence score. Now, a second ago, I mentioned that we think it's about between 60 and 75% heritable, we call it, where it's attributable to genes. We can look at other kinds of setups that would help us to answer that question. One of them is looking at unrelated people who are adopted into the same household. I think I have a pic. Yeah. So here we have pre-adoption intelligence scores on the left here. So you see that the three scores are so similar that two of them are on top of each other. We got the orange one underneath the green one, and then the blue one's a little higher, but it's not meaningfully different. And then they get adopted into either a low socioeconomic household, and you see that their IQ score goes up from what it was pre-adoption, or a middle socioeconomic status household, you get an even bigger increase in IQ score. And then if they get adopted into a high SES household, you see it goes up even higher. So the context is important, right? So if you take people who are unrelated and you rear them in a particular context, you can see the effect of the environment on their intelligence. Now, unfortunately, when you're trying to change somebody's intelligence score or their performance, it's easier to mess it up than it is to improve it, right? There are a lot of things that can reduce a person's intelligence performance. Things like inadequate nutrition while you're growing up, lack of education, just neglect, not having enough stimulation, not enough experiences. There are fewer things that actually quantifiably improve intelligence. That's a lot harder to do. Improving intelligence is a tougher task than ruining someone's intelligence. I'm sorry I said it like that, but that's what it is, right? When we see that you're being adopted into a household with better socioeconomic status, it's partly about, the nutrition is probably going to be better. The education is probably going to be better. The resources to give the child the attention and the things that they need is probably going to be better. And that's what it's like, a whole host of things that go along with it. It's not just about money. There we go. Now, one of the things that we've noticed over the past 100 years of IQ testing is that scores have been rising approximately 3 points per decade over just the last couple of decades, depending on what country you're in, more or less. So about 3 points per decade. That doesn't sound like a lot when your average score is 100 and now it's 103. Does it really matter? But if it's happening for decade after decade, you might be a full 12 points higher, in 4 decades. That's kind of a lot. That's a lot of points. You're starting to get a full standard deviation away. Something that's interesting is that we're observing this change in the richer nations, the more affluent nations, and in the impoverished nations. So I thought I'd share with you this picture that's been used for a lot of bad purposes on the internet lately. So I'm going to make sure that you don't do that. But I want you to see that, first off, this overall pattern where you see every line is going up. Every line, that's an important thing right there to notice, right? All the lines are going up. And you'll notice that if you go back to the very early intelligence testing, 1909 to 1920, pretty flat initially while they were developing the tests. And then as soon as they developed the test, everything started skyrocketing, especially for the countries that were involved in the testing initially. The red country is the Americas, or America, they call it. So this is going to be North America. You see this skyrocketing, right, by 1940. What you want to notice is not necessarily those little individual things, but this overall pattern of growth that we see. You see among Asian countries, it's gone from initial testing at the average. That's not a zero where they got a zero on the test initially. That's a zero where they're at average, right? This is their baseline. So everybody's baseline starts at the gray line. And then you see, just as soon as testing happens, off the charts for Asia, right? Like, what's going on? So there are a couple of things that can explain why we're seeing this kind of Flynn effect. One is better nutrition all around the world. Like, people are eating better than they once did. So if you can fuel the developing brain of a child, you are going to have better performance from that child in the long run. Their brain is more likely to reach its fullest potential if they have good nutrition growing up. So that's a really big, important factor. We throughout the 20th century had famines around the world, but we had aid that would come in and provide nutrition. And so that's a really big protection for people. Other things that have changed are sanitation. So people are healthier and less likely to have dramatic illnesses when they're young. We have vaccinations that prevent people from having really dramatic illnesses when they're young, like polio or the whooping cough or other kinds of things where people are out and sick for a really long time and may have developmental impacts as a result of those. So that's really helped. sanitation, where we're removing garbage and things like that, so people are less likely to have illnesses from those things. So a lot of things around the world have changed sort of simultaneously. Some areas have had it earlier than other areas. You'll notice Africa didn't even really start getting tested until the 1960s, and it was kind of slow through the 80s, and then now it's growing faster as far as the Flynn effect. We see growth all around the world, largely due to better lifestyles as people are growing and developing, and their brains are able to reach their fullest potential. Right. And that's the biggest issue, is being able to reach your fullest potential. Now, I've seen people on the internet use this graph to show, the average IQ score in Africa being lower than other parts of the world. And they say, well, that's, somehow racial effect. But that's not what this chart is really designed to show. I mean, you see that it takes a little while for every country to sort of get to where they are now, right? I mean, the ones who have tested the longest have the most dramatic Flynn effect. And so it takes a little while. I mean, Asia's kind of an anomaly because they had a really quick Flynn effect. The good news is the Flynn effect is starting to level out, because the problem is we have these, look at this, in some countries we're looking at like 30% higher scores than they used to have. That's, the test has sort of lost its intention if everybody's starting to blow the ceiling off of the test. The good news is our tests seem to be catching up. The other good news is it looks like people are having better lifestyles, and that's what's allowing them to achieve their fullest potential. And so that's really good news. All right, I'm going to stop here because I went on a little long on the Flynn effect, and then we'll wrap up with some other factors that contribute to intelligence.